Hey, geometry classes, we're going to review our angles and circles today. We're just going to do two problems together. Remember our angles and circles, we can have central angles, inscribed angles, and we can have angles that are created by tangent lines. That was the newest thing that we learned. So first circle. Make that come up. Come on. Okay, so in our first circle, we have circle T here. And we know that the measure of angle XTU, let's see, XTU, let's label that. This is 50 degrees, okay? And the measure of angle W or VWU is 60. That would be here. And that segment WU is a diameter. So that's this one that goes across the circle, okay? With this, we're going to figure out and just work our picture. You got to take what you got and see how you can use it. In this circle, we have angles that are central angles. So this angle right here is a central angle. And if you trace the angle, you can see that it cuts off this arc. Now, central is same. Okay, central is same. So central equals the arc. Okay, so if this is 50 degrees, you can just bring this out here and say that's 50 degrees. Pretty simple. The other thing we can do with our central angles here is that they told us WU is a diameter. So if we know that this is a diameter, then we know it's a straight line, and that 50 can be subtracted from 180 to get the other side. That's from like the first week of school. So these two are supplementary. They add up to 180. Okay, let's do the same thing. If this is 130 in the center of the circle, if that angle goes to the center, then it's the same as the arc. So the arc is 130 degrees. Okay. Now, it would be really nice to just like use vertical angles and jump that 50 to the other side, but these are not straight lines. See how that takes a turn. So we can't just use vertical angles. We got to use something else. And that's where the 60 comes in. Okay, this angle that's 60 degrees, you look at it and say, how do I use that? Well, trace your angle and see what arc goes with that angle. This angle cuts off, it intercepts this arc. So if this is 60 degrees, now be careful because this angle is not at the center. It's on the circle. So that means that it's only half of the arc. By the time we get to the arc, this arc has doubled its size. So if this arc is 120, then that angle would be half. So 60 and 120. So you just have to look, where's the corner of your angle? Is it in the center or is it on the circle? But since we know this is 120, let's see here. We can go to the other half here. On this half of the circle, this is all 180. So if that's 120, then this would have to be 60 right here. And then let's do our central angles. So from here, this 120 would go to the center. So that would also be 120, which makes this 60 right there. Okay. Now let's switch gears again. This arc also is connected to this angle way over here. So 60, if I cut that in half to go across the circle, because this is on the circle, that would be half. Okay. All right. So lots of things going on there with our angles and arcs. You could keep going further with the triangles, but I know I've got this picture kind of all drawn up. but hopefully that gives you the idea of going to the center is the same measure. If you go on the circle, you have to take half, okay? Or double it. All right. Let's do the next circle. All right, so this one, if you take a look at this circle, we don't really have any central angles. If we look here, the only line that runs through the center here is the diameter, AD. So I guess we could know that this half of the circle is 180 degrees, and this angle right here is 180 degrees. But we don't have any other central angles, so we're always going to be taking half here in this one. All right. DH is tangent to circle E. This was our new thing, that this line, if it only hits once right there and it's tangent, then guaranteed this is going to be a 90-degree angle. Okay? All right, so that's something to keep in mind. Now let's label CDH. So this angle is 40 degrees. And arc, see it says arc AB. So this red one right here is 78 degrees. Okay, that's it. Now, how do we use this? Well, this first one, 40 degrees right here, that angle is actually on the circle. So even though this line comes outside the circle, that angle is part of the tangent there, and it cuts off this arc. So that would be 80 degrees because you double it from this angle. It's on the circle, so you double it to get the arc that's inside the angle, okay? Which that completes this side of the circle. So if this is 80 and that's 78, we know the total is 180. So if we subtract 80 and we subtract 78, I think we should be at 22 degrees right there. Okay, now what else can we do? Well, let's use the 78. So if this 78, that arc right there is 78, we can draw the angle that it touches. So this arc is connected to this angle. That angle intercepts that arc. And so we take half. This would be 39. Okay. If you look closely, there's another angle right here that also goes with that arc. So that would also be 39 degrees. Okay. Let's go here with the 22. What angle goes with that? Arc of 22. This is 22. Just look, what lines connect to that spot? Here and here. So that would make this 11. There's also another one down here. This one and this one. That makes that 11 degrees because you take half there. None of these are going to the center, so we're always taking half. What else? Well, we could check here that 39 plus 11 plus 40 should add up to 90, which is good. And how else can we use this 80? Well, this 80 goes with that angle that's 40. That one's always hard to see. But it also goes with this one up here. This angle goes with the 80. All right. So if this is 80, that becomes 40. Now, if you see we got some triangles in here, we can keep on going if you want to. The only other one I want you to see from the arcs is this one right here, because this comes all the way out to a diameter. So that angle, since that cuts off half the circle, then guaranteed to be 90, because half of 80 would be, or 180 would be 90, okay? And that happens right here also. All right, so a little review there for your angles. I hope that's helpful.